Good afternoon. Good afternoon, everyone. Are we still awake? So, today I want to talk to you about one of our clients, the University of Edinburgh. Before we go on, a few questions. How many people here have deployed OpenStack? A few, okay. How long did it take?
10 minutes.
10 minutes. Excellent. How many taking days? How many taking weeks?
That was 2012.
Uh-huh. And next question. Did you roll your own OpenStack distribution? No? One did. And how many people have upgrade problems? A few. Good. All right. So today, I want to talk about, just to set the scene, let's look at who's who, the client's objective and strategy, where does OpenStack sit, solution design, and then how do we get things into operation, and where things are today. So the who. In this case, it's the University of Edinburgh. Depending on who you talk to, they're ranked number 6, number 7 in Europe. Yep, they're founded a little while ago. I did a presentation about them some months ago, and somebody in the audience said, "Holy shit, that's older than some countries." Yes, it is older than some countries. Organization population, about 45,000 people. So, not the smallest of organization. And then within the university, they have a part which is research services within the IT infrastructure division. They are, in turn, part of information services. And this group of people are responsible for providing operating the university-wide infrastructure for research. How many people do they have? Considering that we have 45,000 people. A grand total of 10 people. Of those, about half of them are in user services, and the other half actually operating the kit. So, not a multi-dozen people team running kit. And so when we look at the organization strategy, considering this type of organization, as in how many people do they have to serve, how many to serve, what size of the user population, they need to focus on how to enable users to allocate the services as they need, self-service. And they need to then focus on using automation as much as possible, because you don't have that many bodies to deploy, right? Ultimately, you need to increase the HR value work. And in relation to cloud, really what they want to do is to provide a flexible compute, storage, networking environment to serve research. So just to clarify, when they talk about research, it's everything other than the administrative stuff. For example, payroll, student records, those are not considered research. Everything else, including teaching, that's research. So where's OpenStack in this picture? Well, OpenStack, the aim of OpenStack here is to provide that flexible compute, networking, and storage. And critically, because they don't have multi-dozen people teams to deploy to run this thing, the OpenStack system should not result in a net increase of workload for the operations team. And they have, in terms of users, they have disparate sets of users, short-lived workloads, long-lived workloads, technical computing workloads, data science workloads, broad range. Importantly, you cannot assume that the service consumers have any particular levels of technical knowledge. And there's workloads that are effectively pets and some other applications, some other workloads that are cattle type of applications. So then came the partner. That's us, and hopefully not a partner in crime. So we are a cloud platform software company, presence in Slovakia, Romania, Russia, and the UK. Our focus is enterprise. Customers that are running non-toy systems. The team's expertise, we all came from large-scale systems. Some operating systems in telco, finance, defense, government, and such. So let's look at a solution. When we design a solution, we plan for production from day zero. You build for production from day zero. And considering that we're not building a toy here, is HA therefore optional? Absolutely not. And then when we're going to scale this thing up, that process should also be that easy. It should be monkey capable. And when building the solution, we therefore need to consider the full life cycle from deploy into operate into upgrade. So in this particular case, the solution design management nodes of 16 nodes, 9 Ceph storage nodes, and the starting point for compute was circa 200 plus nodes. And once we get past the definition of, okay, this is the kit needed, this is the kit that we're going to use, let's get to deployment. Here, we build, we first use Foreman, get the base OS up, and following that, there is some post-OS deployment configuration using SaltStack. The client organization uses SaltStack already. And from there on, we deploy the OpenStack and Ceph layers. Given that the client already used SaltStack with an organization, we chose to use the SaltStack variant of FishOS Deployer. We also have an Ansible variant. So the principle here is really mature technology, something that enterprises already use, nothing fancy. So with that, you provide the input in the configuration and file and inventory files. You run deployer, get 2 cups of coffee, and we're at showtime. Now, OpenStack is wonderful. Comes with new releases every 6 months. OpenStack is wonderful with new innovations every 6 months. At the same time, OpenStack is also a massive headache every 6 months. And that's to put it mildly. Some people would say it's absolutely shit. So, broadly, you're looking at n to n+1 upgrades every 6 months. Yep, generally you can look at holding out over n years, but really the more reliable thing to do here is n to n+1 upgrades. So given that we're not operating a toy, what do we want? As an operator, what does an operator want when you're not operating a toy? You want this thing to continue running at all times. The last thing that you want is that 45,000 people coming, screaming, shouting at you, going, "Oi, why is it down?" So, therefore, upgrades, it has to with very simple, 0 downtime. And but then you scratch your head and you wonder, geez, how do I do that? Ah, right. The solution architecture, going back 6 months before, you've got to get it right. If you didn't get it right, 6 months later, you have an oh shit moment. And yeah, you need the upgrade to be, again, monkey capable. How? Well, first off, high availability, this is not a luxury. And when you look at cloud, you've got two sides of the equation. You've got the operator and the service consumer. The service consumer says, I don't care what you do to provide me with the service. I am only interested in using it. I'm therefore only interested in availability and reliability. Infrastructure? Pfft, none of my business. So any time when the service is not available to the service consumer, whatever the cause may be, that's a downtime. And then let's take downtime risks, split into two parts, intrinsic versus extrinsic risks. Here, I want to focus only on the extrinsic risk. Intrinsic risk, that's a longer conversation. Come talk to me, and I can go through that in a little bit more detail with you. So extrinsic risk, here broadly what we're talking about is how do we deal with extrinsic risk using a highly available solution architecture. So what's OpenStack? HTTP, databases, and MQ. Anything else? Anything else, anyone? Nope. That's it, yeah? So we know we can then take the services, we further split into two parts. Those with data and configuration. And those with configuration only. The ones with data, really, how do we safeguard the data? Replication, replication, replication. Here, we've got a choice of either odd node model or the even node model. So, odd node model being the quorum model. This is essentially traditional HA operations model for data. Are we inventing anything new? Nope. And when we look at HTTP services, hey, it's a web server. let's treat it as such. It's not complex. And we use traditional HA model for web servers. What about MQ? Well, the principle in MQ is you put stuff in, you take stuff out. So what do? We replicate the reader and writer. Anything else? No. So in short, to deal with extrinsic downtime risks, we keep a copy available at all times. And the smart, yep, it goes back to solution architecture. Get it right, it works. If not, it'll come back and bite you. And when it comes to upgrading the management nodes, here you're effectively taking 1 over n, where n is greater than 2, you upgrade that. You bring it back up, you bring the other 1 over n down. You upgrade that, bring it back up. That's the general principle. But then along the way, yep, there's some black magic that you need to figure out because there are schema changes, there are this, and there's that. So the upgrader, therefore, needs to handle those cases. Essentially, it needs to do black magic. And what about the compute nodes? So compute nodes, essentially what we do is that we take a, so let's suppose you have a pool of 100 compute nodes. What we then do is we pack the workload onto as few servers as possible to cater to that workload. In FishOS, in our product FishOS, there is a decision engine that will handle this packing of workloads. So we pack it onto as few servers as possible, therefore freeing up a set of n nodes. That becomes our working set, and then we move across. And yep, there are edge cases. What are some of the edge cases? For example, the VMs that won't complete live migration otherwise. So edge cases, yep, you need to handle it. And again, this is where we use some of our technologies to figure out why is it not completing live migration. And to get that why, this is really where you really need to understand what is going on in a machine. And no CPU, memory, disk, and network is not going to suffice. And once you figure out those edge cases, you can therefore make sure that migration completes. Job is done. Simple. And of course, all this is enabled by the right solution architecture. So where are we nearly 2 years later? It's worked well. It's growing. They're growing by another, most recently they've grown by another couple thousand cores. And the system is under normal circumstances, as in nobody goes on holiday. This whole thing is supported by a massive army of one guy. Dead easy. And so the other stuff in the bag that is provided by us, we provide the integrated log management, monitoring, service health management, resource management, billing, capacity planning, so on and so forth, pre-integrated. Now, considering that an operator that is not building a toy, the operator's business is not to string together OpenStack components. The operator's business is to not have fun figuring out how the hell to integrate. Then, this is where the operator benefits from our tools, from our integration. And this is then delivered in multiple manners through software only, fully integrated with hardware, managed hosted together with some of our hosting partners. The whole principle is that we're a products company. We build products that just work. In the sense that you do not ring up Daimler to say, "Oi, Daimler, I need a taxi to go from point A to point B." Right? Daimler built you a car. It works. That's our business. And we build a product that we can then amortize across a large user base to enable our customers to run the system in an efficient manner with low TCO. Some of the other sites not far from here, or rather in this part of the world, an operator that went from bringing up the base OS to having full cloud running in the data center, 3 hours. Financial services player, they run 4 data centers, manage as one with us. And at another site, it's a banking organization. They run 3 data centers in the HQ location with us. You can take down any data center, it'll still keep running. A larger government site, they run 150,000 VMs. Sizable. And a couple other sites in the UK, one whereby we went into retrofit fixing another vendor's earlier installation, which the client found problematic. And those are in R&D and in aerospace design facilities. Questions?
How do you deal with the networking layer? You talk about OpenStack being database and messaging and whatnot. How do you deal with networking in terms of upgrading Neutron?
What's the problem with it that you're facing? It's networking as usual. First, we operate with DVR. So once we flush the VMs, traffic is moved. Therefore, enabling us to upgrade the other nodes. And then we flush back. Yeah. Any other questions? Now, here's one offer that we're making. Come talk to me, a client in any vertical, but we'll only provide one free system in one vertical in this region. So, want a free system? Come talk to me.
Okay.
Okay? Cool.
That sounds like a very good deal. We still have quite some time, so I'll just ask one more question.
Sure.
So, what is the next, let's say, feature that you plan to build in for FishOS?
So, a number of things. Some of our customers are really wanting us to further build out our health engine. So, look at it this way. Increasingly now, organizations have this young developers who grew up in the Amazon era. What this means is that they have gone to Amazon, they point and click, they got a VM and they learn how to code. Yeah? Fantastic. They show up at work and they say, "Oh, geez, the company has a private cloud." Fantastic. A week later, you, the operator, goes along and you say, "Hey man, the system is down." At which point the young coder looks at you going, "Why the hell are you so bloody incompetent? Why can't you just make it work like Amazon?" Always, at all times. And so then the operator scratches his head going, "Ah, crap, how do I do that?" this is where our health engine comes in. We look for the 6 states, not just the dead and alive states. Whereas traditional IT monitoring, what it is, you probe, it responds, you say, yeah, great, it's alive. Next cycle, you probe, yep, still alive, fantastic. Next cycle, you probe, it's not responding. Don't quite know why. You probe 3 times, still not responding. Right, let's call it dead. But by the time you call it dead, that young coder over there is going to scream incompetence. So our health engine is to enable this preventing the young coder screaming incompetence. And some of the clients are asking us to further build out that capability to integrate hardware. So, for example, situations where one that we've done recently, integrating in data for power supply units. So some organizations like to run only with one power supply unit. You may say it's risky, until when you look at the organization size, for one system, they run 10,000 nodes. And organization-wide, their fleet size is about 150,000 nodes. At which point, you say 150,000 nodes, conservatively $100 per power supply unit. It's no longer a $100 power supply unit anymore. So we've built those integration to figure out when the power supply unit is about to die, but not yet. Because if the power supply unit goes kaput, your workload goes kaput. Yeah?
All right.
Okay?
Thank you.
Cool.
Yes. Let's
Thank
thank
you.
the speaker.